In this video, we're going to solve limits using the direct substitution method. So in previous videos, when we solve limits, we've been breaking it down by looking at the behavior of the function from the left-hand and right-hand side. However, you might notice that it takes more time and work to go through these steps. So a faster way we can solve limits is by the method of direct substitution. As the name implies, when using direct substitution, all we have to do is directly substitute the x value into the limit. And this only works if the function is continuous and defined at the x value. So let's look at this example. Let's say we want to evaluate the limit of x cubed plus 2 as x approaches 1. Well, we know conceptually that the function x cubed plus 2 looks something like this, and that is continuous and defined for all real numbers. So we can plug in x equals 1 into this function to get that our limit equals 3. Now let's look at more problems. Here we have two problems and we want to use the method of direct substitution to solve them. For our first problem, we have the limit of x plus 2 all divided by x plus 1 as x approaches 4. At x equals 4, this function is continuous, so we can plug in 4 to find our limit. So we have 4 plus 2 all divided by 4 plus 1, and this will give us 6 over 5. Now let's look at our second limit. We have the limit of 1 over x squared as x approaches 0. And you notice, at x equals 0, we have an asymptote. Therefore, it is not continuous. So we cannot use the method of direct substitution, since at x equals 0, the function is not continuous. However, this does not mean this limit is undefined. If you graphed 1 over x squared, and you look at the behavior of the function as it approaches x equals 0 from the left-hand side and the right-hand side, you will be able to find the limit. So whenever you're using the method of direct substitution, make sure that function is continuous at that x value. So in recap, the method of direct substitution is a way to solve limits by substituting the x value into the function. And in order to use direct substitution, the function must be continuous at that x value. Thank you for watching this video and hope to see you next time.